students. All right. That was a strange phrase. All right. You guys, anybody questions? Anybody questions about anything?
Can you go over number 20 from the practice final, please?
Let's do this. Let's do this. Can you hold on to that?
Yeah.
I'm going to do two things from section 13.4, and then we're going to devote the rest of this class to starting to look at the practice final. And then we got 2 more classes this week where we'll just keep on reviewing. So just hold on to that for me. Bring it back up when we're done with chapter 13. Anybody else questions from homework or corrections on anything or? Okay, all right. So some of the homework in section, all right, let's do this. I had some really good questions in office hours. So I want to kind of help you guys out with a couple of these because they do get pretty freaky. In fact, what I would highly suggest you do, let me do this. This little section right here is deceptively easy looking, possibly. I don't know. But when you sit down, you really start to look at it, it gets a little freaky. So what I would suggest, to be really honest, is to work in this section. Rio, what did I assign in this section? Let me see.
21 to 24.
Beautiful. I love it. I would actually, all right, if I were you, if you do 25 and then 24, and you just work backwards, it will actually make some of this earlier stuff easier. Because this is kind of based on something you do earlier here. This, no, let me do this. All right, I'm about to give something away. Okay, but this is something that I really want you guys to see. I kind of hope some of you guys have seen this before. I know one of you have, or some of you have because you were here in office hours. What sequence is this? As I try not to miss anything.
1 squared, 2 squared, 3 squared, 4 squared.
This is squares. I love it. Now, so that would be the sequence. If this was the sequence, if this was the A sequence, what would A n be? It would just be n squared. Is everybody with me? That's not amazing.
Yeah.
The first one is 1 because 1 squared is 1. The second one's 4 because 2 squared is 4. Ooh. Now, there's something else about this sequence though. What do I add to go from 1 to 4? That's right, guys. 3. What do I add to go here? That's right, guys.
5.
And then I add
7.
7. What's happening? What are those? What sequence is this?
Odd number.
Odd numbers. Has anyone ever seen that before? That all the square numbers are separated by the odd numbers in order. Have you guys ever seen that before? Anybody? No? Yes? You don't care? Screw this shit, Jeff. All right. Okay. Oh, I got a chat going on. No, that's cool. I think I agree with you. Isn't that cool? I mean, that's the last thing you would sit down and really expect, that the square numbers are separated. But watch this, real quick, just go with me. Here's a visual. Here's 1. Here's 4. Here's 9. Are you guys cool with what I'm doing? 1 dot, 4 dots, 9 dots. And of course, don't they make little squares? Well, don't I have to add 3 dots to 1 dot to make it the next square? Don't I have to add 5 dots to 4 dots to make it the next square? Do you guys see what I'm saying? So that's the visual representation of why it kind of makes sense that they're separated by odd numbers. All right. Anyway. Will this help you immediately with your homework? Yes, it will help you with your homework. It will. One of the problems you have to do is related to this. But is this just cool to know in general? Shit, yeah. Let me think. I used to know, come on, Jeff, you could do it. Shit and a half. I used to know, tell me what you used to know. Oh, that's it. Watch this. This is kind of cool. All right, isn't this 4 squared and 5 squared, right? Right. Isn't that 4 squared 5? What's 4 plus 5? All right, isn't this 5 and isn't this 6? And what's 5 plus 6? Right? No, okay, whatever. All right. Anyway, so if you base, so if I know 12 squared is 144, what do I add to 144 to get 13 squared? I add 12 plus 13. I add 25. All right, let me stop. I don't know if you're interested in this. You can kind of build on that yourself. It's a neat thing to realize, and it's what people use sometimes to do squares really quick. You just have to memorize some squares, and then you can build any other square you need off of what you know. Trippy, that's right. If you're not interested in this at all, you never have to know this. I never had to show you this. This is not a requirement for doing math. This should be a byproduct of doing math. So it's possible to have different sequences equal the same thing. How do you mean exactly? Equal what? How do you mean equal? And what do you mean? A different sequence with the same generation function? Like different equation equal the same sequence. You can have, well, all right. Normally, if you find a different generation function, like a different AN, it's just the same AN reorganized or simplified or written a different way. Does that make sense? Okay, maybe. Now you actually could write a sequence with recursive formula, but also find an explicit formula for it. Are you with me? Remember what recursive formula means? What does recursive sequence formula mean? What's an example of a recursive sequence formula we've used? Anybody remember? It was something yesterday started with an F.
The Fibonacci.
Fibonacci. So remember, it was AN equals AN minus 1 plus AN minus 2. So it's recursive means you don't have a formula for the nth term that you can find directly. It's based on terms before it. Recursive formulas kind of suck because I can't get to the 800th number in one step. I have to get to it in 799 steps, or in this case, 798. But anyway, I don't know if you guys are with me or not. So you can have a recursive formula, but then figure out an explicit formula. So you sort of have two equations to lead, but they're like two entirely different thought processes. I don't know if you're with me or not. So that's a good question, Kurt. I'm just trying to expand a little bit on it. All right. And a little thing about 23. Do you see how some of these are fractions? Do you remember yesterday there was a problem I made up and I said, I'm going to be nice. And I wrote like 6/8 instead of 3/4, right? I didn't reduce it. I said I was being nice. This problem is being mean. Some of those have been reduced. So you have to go into it realizing that you want to unreduce some of these numbers to be able to see the pattern. And you should certainly see some things that will help you figure out exactly how to unreduce some of these. All right, I'm going to stop. Also yesterday, I really want you to see how I tried to get you ready for this homework. Also yesterday, we did something where it was, it was this. It was 1, 3, 7. Do you remember doing this? 15. And that was 1 away from being this, which is 2 to the n. So this would be 2 to the n minus 1. Remember that? Do you guys remember that? No? I really want you guys with me. I mean, this isn't automatically like, all right, you should know this about pre-calculus, but you can't always find an example that's exactly like what you're doing. You find examples that give you ideas of what to try, right? So here's an example of a problem where the sequence I'm given, if I add 1 to each of them, it becomes easy, which means my sequence is the easy thing minus 1. Done. Yay. That might help you with, I don't know, one of these here. I don't know which one. Okay. Is it gonna necessarily be 1? No, it doesn't have to be 1. It could be like 2 or 3 or something. I don't know. 4, 2. Could be 2. All right, let me stop. I'm gonna clear all this away. Anything else, guys? Did I miss anything in chat? Chat is very quiet. Okay. Anything else from homework stuff? I was trying to help you with this section here. All right, so let's do this. Am I recording? Yes. I am going to turn off Angel's Landing behind me. Come on. Every time I do this, it takes longer. Okay, come on. I got a new trackball mouse. Have you guys ever had a trackball mouse? I'm trying to get used to it. I used to have one of these, and they are so freaky, but they're awesome. Okay, all right. Now, so we have one section. I made 13.2 and 13.3 extra credit. 13.2 is arithmetic sequences, which I talked to you about. 13.3 is called geometric sequences, which are based on multiplication. Oh, yeah, that's true. You don't want to game with those kids. Learn from Jordan. Now, I want to do 13.4, and then we're going to devote the rest of class to starting to do review for the practice, for the fun. Whoa, that's really up there, Joe. So what we have in 13.4 is an idea that will come back in later math classes. Even if you don't take it, we're going to talk about it right now, so it doesn't matter. But if you take them, I want you to be ready to say, I've seen that shit before. So it's sort of a way to write. All right, stay with me now. All right. We just did something like this a second ago, but 2, 4, 8, 16. What would this sequence be? How could I define that sequence? What would be the generator to make all those numbers? What do I keep doing?
2 to the nth power.
Yeah, I keep multiplying by 2, right? So this would be 2 to the first, 2 squared, 2 cubed. So it's going to be 2 to the nth. Okay, is everybody with me there? Are you guys with me? All right. Now, that's section 13.1. Section 13.4 says, all right, what if I have this? Is there a way to write that more concisely? So this is, of course, a sum. This is a sum of elements of a sequence. And in fact, I'll be more specific, sum of n elements. In this case, 1, 2, 3, 4, 5 elements. All right. Very different way to say it's adding a bunch of numbers, but it's being a little more specific. So what I want to do is I want to create a symbol that represents all of this shit. Because in mathematics, we don't like writing a lot of phrases. I want a single symbol which represents this idea. So what we do sometimes in mathematics is we say, well, the word sum is important. Greek letters look neat. Let's use the Greek letter S, capital Greek letter S, to mean sum. How's that sound, everybody? That sounds good. Greek is freaky, right? Students already think math is Greek, so we might as well make it actually Greek. Does anyone know what the Greek letter capital S looks like? Has anyone ever seen that? I'll tell you the word for it. No, it's not really a Z looking thingy. It's called sigma with an M. I like that, sigma. It looks like an E, actually. It looks like this. So this is, oops, I need some room here. This is the letter sigma. All right, if you ever take statistics, Greek letters will rule your life. So And we use every version of the letter S in statistics. Now, I want to sum up 5 elements of this sequence. Right? I want to sum up, I forget what this book uses, but I'm going to use something we use a lot. We use the letter K a lot here. They might use the letter I. I probably should have looked this up. I don't know. Depends on what class you're in, what book you're using. What does this book use? You're nowhere near the right section here, Jeff. There you go, buddy. Sorry, I just want to be a little bit like the book for once. Oh, they do use K. Good job, book. All right. Are you guys roughly with me? So if this means sum up some elements of, and then I fill it with the sequence, sum up some elements of this sequence. So this symbol by itself doesn't mean shit. It needs something next to it. Sum up. All right, I need something in there so I can sum them up. Now, what's still missing though? How many elements do you want to sum up? Do you want to sum up all of them forever to infinity? How many do I want to sum up? If I'm trying to write this, how many? 5. Oh, I'm sorry, Kurt. So he's always in the chat with answers. So now watch this. I really want you guys. So there were all kinds of decisions that could have been made differently, but they were made this way. So we live by this. So watch how we identify this. I want K to go from 1 to 5. So what this means is sum this up from K equals 1 to 5. Wouldn't that give me this? What is it when K is 1? What do I get? 2 to the first is 2 plus, because it's sum. Then let K be 2. 2 squared is 4. And so I would get this, wouldn't I? You guys? So it's just memorizing what. So this symbol means sum. So I'm going to have these elements separated by plus signs. And how many of them I'm going to have from 1 to 5. Now, can you write for me what this would be? What can you just write for me like this? This is this. Can you do the same thing for what I'm about to put here? What are you going to put there, Jeff? I don't know yet. Okay, man. Let's do this. Sure. All right, I like it. So just write down what that sum is, like this. Is that true? I think so. All right. Jeff. Oh, well, it's too bad, Jeff. That's fine. All right, where am I at? Where am I at? There you guys are. So somebody got that yet? What do you get? What do you get? What is K at first? What's the first value of K? What does K go from to? This K goes from 1 to 5 here. So that's why we get 2 to the first, 2 to the second, 2 to the third, 2 to 4, 2 to 5. What does K go from to here?
3.
It goes from 3. So what do you get when you put a 3 in?
9.
9 minus 5? 4. And then you go to 4, and then to 5, and then you stop at 6. Do you guys see how this works? This is kind of nice. This says go from 3 to 6 evaluating this, and whatever you get, add them all up. That's what that symbol means. So 4, 16 minus 5 is 11. 5, 25 minus 5 is 20. 6, 36 minus 5 is you can do it, Jeff, 31. And then you just have to add them up. 3, 4, 5, 6. Very good. 15, 35, 66, right? Okay. All right, so it's new. This is a notation probably you haven't really seen before. I don't know if anybody's seen this notation before. Summation notation. Okay, all right. No, but is it difficult? No, it's relatively easy. Relative. All right. All right, now I'm gonna erase all this. You ready? Does this get weirder? Hell yeah. Is this just the beginning of this? Yes, it is. All right. Will we see a lot of the weirdness? No, no, we won't, unfortunately. I want to show you two things. I want to show you one little thing that I didn't learn until much later, but I'm going to tell you right now. So this means, so real quick, and sometimes they use the letter I. So let me just do an example of I, just so you know it's out there. So if I had this, I is 1 is 3, and that means plus. If I is 2, that's 9, plus. If I is 3, that's 27, and that's where I end, right? All right, no problem. Now, the next thing I'm about to show you, you do not have any responsibility for. I just want to show it to you, because I didn't get to see this until way later in my math career, and I can just show it to you right now. Why not? We have a symbol that means add up the terms you get when you go from this to this. That's what that symbol means. There's a symbol that means multiply. It's this giant, let me make this even more pronounced. It's a giant pi symbol. I don't know if you guys are with, so if I write the same stuff here, this means figure out the sequence numbers. When I is 1 is 3 times. So this symbol means multiply each thing you get. When I is 2, I get 9 times. When I is 3, I get 27. And then whatever the shit that is that 729? I don't know. I think that's what it is. I don't know if anybody's interested in that. Isn't that interesting? No. This isn't used very much. This is why you don't see it, but I figure I might as well show you. We have a symbol that means add up a bunch of things. We have a symbol that means multiply a bunch of things. Yay. Okay. All right, let me ask you a quick question, and then I'll show you the last thing I'm going to talk about. Can you imagine if I went to infinity with this specific one? What would that sum be? What would that sum? Don't overthink this. If I took all these numbers to infinity, let the I go to infinity, what would their sum be? Infinity. Isn't that cool? That doesn't take much thought. You would go to infinity pretty quickly. So that sum would be infinity. Would go to infinity. Now stay with me. Stay. This is all right. I'm really sorry. This is nothing even you have to know. I don't care. Can you think, is there a way that I can add an infinite number of numbers and they don't come out to infinity? Have an infinite number of numbers and they do not add up to infinity. What people sometimes forget when I say numbers. Okay, I like that. You can have an alternating sequence. So let me say this. Is there any way I can add up an infinite number of positive numbers and have it come out to be something other than infinity? There is. You ready? It's really cool. Once you see it, you're like, of course. So what if I do 0.1 plus 0.01 plus 0.001 plus 0.0001. Is that an infinite number of numbers if I keep going? Does anyone know what that adds up to be? Wouldn't that add up to be 0.1111? All right, give me a minute. No, screw that. All right. I mean, are you guys with me? Not only is that not even infinity, it's not even 1/4. It's not even what? I don't know if you guys know, but this is actually equal to 1 divided by 9. This is actually equal to 1/9. All right, sorry. I just want to show you an example, because when you hear that, can you add an infinite number of numbers, positive numbers even, and have the answer come out to be less than infinity? You're like, what the shit are you talking about? If I add up an infinite number of numbers, it's going to get crazy big. No. I like to look at this as the next term gets out of the way. The next term gets out of the way. They never even add on to what's here already. They move to the next spot. Isn't that kind of cool? Is there another way to do it besides this? Yes. Where would you learn this kind of shit? 280. Calculus 2 is where you study the shit out of this. Oh, shit. All right, one last thing for me to go through, and then we're going to transition to review. All right. If I said add up all the natural numbers from 1 to 100, well, I might as well tell you the whole story. There are actually urban legends in mathematics. They would not make a good movie, but there's an urban legend in mathematics that there's a mathematician called Gauss. We use his name. His name is actually a measurement of magnetic field strength. I mean, that's the exact Carlos. The ultimate place to be for a mathematician is to have your name on a theorem or as a unit of measurement. So a Gauss is how we measure magnetic field strength. Is that necessary to know? I'm sorry, no. So supposedly when he was in, he was 6, he's in class. The teacher's just like, holy shit, everybody's going insane. And he goes, hey, stop it. Everyone sit down, and you will add up all the numbers from 1 to 100, and you don't say a word until you're done. If you say something, you go to the office. Right? Whatever. So he thought that was going to take him a while. Gauss was done in roughly 7.2 seconds. Little jackass.
1 plus 100 times 50, right?
You got it. I love it. Right? Well, it take away my punchline. That's all right. So obviously, if you do 1 plus 2 plus 3, 6 plus 4, then that's going to take forever. But 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. How many times will I have 101? How many pairs can I make?
$50.
Yeah, 100 cut in half. Does that make sense? 100 numbers. So I can make 100 divided by 2, 50 pairs, and each pair will add up to 101. So here's the freaky thing. You ready? If I add up all the whole numbers from 1 to 100, the answer is 50-50. Isn't that kind of neat? Isn't that kind of a semi-neat thing to know? Am I saying you're going to be popular at a party if you bring this shit up? Probably not. Parties I go to, maybe. So what is this? How do I? All right, let's see if you guys remember. This works. This works for any sequence that is arithmetic, where I keep adding the same number. It works for any sequence where I keep adding the same number. So how did we get this? What's the general idea? I take n divided by 2 times a1 plus an. That is the quick way to get the sum of any sequence built on addition. So for example, is this sequence built on addition? You can do it, Jeff. There you go, buddy. Right? Is that sequence built on addition? Did I write that right? It looks like it did. Good job, Jeff. Yes, okay, thank you. So I'm gonna have, so I got 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna have 8 divided by 2 pairs, where each pair is 3 plus 31. Right, 7 plus 27, 11 plus 20. So what am I gonna get? 4 times 34. I get 100 and what is that, Jeff? You could do it. 36. Do you guys see what I did?
So,
Go ahead.
so what about the number of the numbers is odd, just like
Oh yeah, that's cool. All right, give me a second. It'll be fun. Real quick, let's double check this. 10 plus 11 is 21, 36, 55, 78, 105, 136. Check. The Ting has a really good question. Let me show you real quick how this works. If I have an odd number of numbers, let's see, let's make this nice. Jeff, dude, I meant to do 3. There you go, buddy. There you go. Let's just do this. So there's an odd number of numbers, correct? But watch how it still works. 22, 22, half of 22. So that's why you get like a half of a pair. So if I do this officially, 1, 2, 3, 4, 5, I have 5 halves pairs where each pair makes 22. Half a pair makes sense because that's the 11 in the middle. I like it. So it even works. So 2 goes into 22, 11, 5. If you add them all up, you get 55. Okay. All right. Now,
I got it. Thanks.
sure. The reason why I went through that a little quickly and didn't really formalize much is because I'm going to go ahead and make 13.4 homework extra credit. I'm going to change it right now. Unless you guys want me to keep it as something that you have to do. Do you want it? Is that what I'm getting? You guys don't want me to do that? All right, you guys want me to keep it as a normal homework assignment. I understand. I can do that. You don't want me to make it extra credit? All right, I can leave it alone. I got 1 vote for extra credit. 2, 3 points, 3 votes for extra credit, 4 votes, 5 votes for extra credit. Okay, I guess I'll do it. Okay. Just craving my interaction, man. I got to get my hit of interaction. Do I have a late votes coming in? Late votes coming in. People were in the other room and they're like, I heard the words extra credit. Let me come back. All right. All right, just to help you guys out with homework, the most important thing is if you're behind on homework, you do the homework first. If you haven't corrected something, you do the corrections. And now that I've made the last 3 sections are extra credit. So that should help you. You only do that if you have time, right? All right, so it's officially changed in Canvas. If you look at it, 13.2, 13.3, 13.4 all say extra credit. No worries. So let's focus the rest of today on getting ahead or starting to look at reviewing for the final. And the way this is going to work is you guys need to ask me some questions. And if nobody has questions, we're just going to leave. And then I don't know what we're going to do tomorrow. So it's really predicated on, you just said predicated, Jeff? I did. On questions that you guys have. We can kind of just start looking at some of the practice final. Somebody pointed out to me that past Jeff, I think last semester I had done some of it in class with the students. So they're not really on the practice final solution video. So we can do some of that if you want to. Let me see if I can get a copy of this. Oh, where are you? 176 practice final. There you are. What does this look like? This looks good. Oh shit, that's not good, Jeff. Oh shit. Let me see. That's not good. All right, let's see. That sucks. Hold on, guys, hold on. Well, that sucks a lot. All right. Hold on, everybody. Hold on to your butts. All right, let's see. Boom, 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 boom. Boom. So get ready. Everybody get your questions ready. Has everybody at least kind of glanced at the practice final? If not, tried some of it out? No? Oh shit, what am I doing? Somebody has left the room. Can I ask questions about the midterm? Of course, yeah, everything's on the table. So it's really up to you guys what you want to focus on right now. We have 3 days now. We have the rest of today's class, we have tomorrow, and we have Thursday to talk about whatever. Right? So what do you got, Paul? I think it was Paul, right? That was asking me that. Uh-oh, chatting at me. Hold on. The midterm problems to clarify. What I don't understand what you mean. Ask me something.
So what will the final cover? Things
Oh.
after the midterm?
No. Final's cumulative, like every math final is supposed to be. So what I mean is everything. It will cover everything that we've gone over this semester. Holy shit. Will I be able to put everything we've gone over the semester on there? No. I'm gonna have to throw some stuff out. Exactly what am I gonna throw out? Well, let's see. We're gonna all find out together. That was fun, Jeff. Like ask about 1A. Okay, sure. All right, let me see. So you got a question from 1A on the midterm. So this is how this is going to work, everybody. Whatever you want to focus on. If you have a question specifically from a quiz or a midterm or a homework or the practice final, ask that question. If you're like, I forgot how to do trig identities, then I can make some shit up and we can do some problems like that, right? It's really wide open to whatever you want to talk about. So I'm sorry, let me do this real quick. I'm getting something ready for later. All right, there we go. And then, all right, there we go. All right, Jeff, you could do it, buddy. That sounded like you were there. I wasn't. That's too bad. All right, hold on. Hold on to your butts. All right, come on. No, that doesn't. That's not how it works. All right, hold on. There it is, buddy. There you go. I know computers. All right, there we go. Okay, got that ready. So your question is on 1A on the midterm. Okay. All right, let's see. All right, here it is. All right. Midterm 1A. What did 1A look like? So not everybody had the exact same problem. Oh, 1A was just a log problem, right? 1A was a log kind of problem. Oh, shit. Hold on. There we go. Here we go. Let's see if this will work. No, you open on the wrong. Oh, no, it's on the wrong thing. Damn it. Damn it to hell. Let me see if we can do this. Yes, I can. Maybe if I had my old mouse. This is really weird. There we go. All right. Does everybody see my whiteboard? Oh shit. No, you don't. Hold on.
Yeah.
There we go. Okay, now. So, all right. I already forgot what it was. Damn it. What was that specific problem? Oh, okay. All right. So everybody, I think everybody had a problem. Well, first off, can you guys remind me what log base 4 of 16 is, for example?
2.
Why?
Two
Why?
squared is 16.
No. Try again.
It's a base 4.
4 squared is 16. Okay, I like it. So remember, the answer to a log is always a power. It's the power that the base needs to become the inside. So what if I had this?
One half.
Yes, because 16 needs to be square rooted to become 4. Is that all right? Do you guys see that? Do you guys remember this? All right, there you guys are. How do I get you over there? Shit. All right, there's got to be an easier way to. There we go. Hey, all right. Is that all right so far? You guys okay? So what would log base 64 of 4 be?
1/4.
No.
What?
What?
1/3.
There it is. Why 1/3? Because 64 is 4 times 4 times 4. So I have to take a cube root of 64 to make 4. Now, again, what if you had no idea? What if you're like sitting out there, I have no idea what the hell this guy's talking about? I never do. Who is this crazy asshole? Remember, you could do this. Do you know the answer? No. So we'll call it X. Then can't I write this as 64 to the X equals 4? Is that cool? Right, because the answer to a log is always the power that the base needs to become the inside. That's what the answer to a log always is. What's happening? Treats how I wrote it. I don't know what that means. Treats how I wrote it. Oh, that's how I wrote it. Okay, I don't understand. So if you have a specific issue, like you're not sure why you lost points on something, keep that for after class. I don't know if that's what's happening. You got stuck. Oh, you got stuck on this step. Okay, that I can work with. All right, I got a lot of questions coming in. You guys are gonna have to hold them. Can I rewrite 64 in terms of this? 64 is 4 to the what? I love you guys. More questions. I need answers right now. 64 is 4 to the what? What's happening? 64 is 4 to the what power? Oh, there's a chat. I can't handle chat when I'm sharing. Okay, 3. That's
3.
true. Good. 4 cubed is 64. This is 4 cubed to the x, because all I did was replace 64 with what it is. So that's still there. So 4 to the 3x equals 4. What's up here on the 4? What's up here? What's the power right here? Oh crap, chat. 1, yes, okay. So what must be true about these two?
3x equal 1.
They have to be equal to each other, of course, right? If 4 to the 3x equals 4 to the 1, well, 3x has to equal 1. That's the only way that could be true. So then I get x is 1/3. Finally, I get the 1/3 that we got earlier. So I don't know if you guys remember that. We went over that. No, yes. That's another way to do that. If you can't quite see it directly, you can always rewrite it like this. Now, let me catch up on the seemingly infinite number of chats I just got. Hold on. Whoa, there's another one. All right, can we review converting equation? Holy shit. Okay, that's a long thing. All right, I got a lot of little chats to look at here. Let me do this in order. Scheisse. This is a bad night to stop using my old. Yeah, screw it. I'm gonna turn my old mouse on. Screw this. Are you working, old mouse? No. Old mouse. Old mouse, what happened to you? Old mouse. Right there we go. Hey, all right. Sorry, guys. All right, I'm back. Oh, I see why you keep doing that. Gosh. Number 3 on the midterm. Okay, number 3 on the midterm. Let me stop this. Oh, yeah. All right. Okay. Yeah, everybody really hated this one. Ooh, that's neat. I didn't know that this shit stayed here. All right, now everybody's number 3 on the midterm was something like this. Hold on. Two numbers add to, sure. Two numbers add to 64. We increase one of the numbers by 7 and multiply that by, yeah, we increase one number by 7, Jeebus, and add that, right? Wait, multiply that, Jeff. Multiply that by the other number. Okay, so everybody got really, really lost in this. Find the maximum product, is that what? Yes. Find the maximum product. Okay. Now, somebody help me out. What are the two numbers? What are the two numbers?
A, B.
All right. Oh, those. All right. I'm going to say, yeah, sure. A and B. I like it. I'm tired of using X and Y. So A and B are my two numbers. What's the first thing say that happens?
Equal to 64.
Good. So A plus B equals 64. That's one equation. That's what they tell me. Now, what else? If we increase one of the numbers by 7, so of A and B, which one do you want to increase by 7? It doesn't matter.
B.
Sure. And multiply that by the other number. Okay, so A times B plus 7. All right, let me stop for a minute. Is everybody with, all I've done is exactly what the problem tells me to do. Two numbers. All right, I'll call them A and B because I don't know either one. Add to 64. Okay, A plus B is 64. Thank you, problem. We increase one number by 7. Okay, it doesn't matter. So I'll increase B by 7. And then we multiply that by the other number. Okay, that's A times B plus 7. All right, is everybody with me? I'm just following along with what the problem is telling me. And sure, I'm going problem. I think you're drunk. But let me just do what you're saying, right? Find the maximum product. So this is the product function. How many variables do I have in this product function? How many inputs? 2. That sucks. We can't handle that. We can't do it. We can't handle it. But thankfully, I know this. Remember, tell me, ask me. Can you use what they tell me in what they ask me? Does this give us any information about A or B? Can you? Yes. Okay. Yes. That's an answer. Sure. Yes. More specific now. Sure. Yeah. I could. All right. I need you guys with me. Can't I solve for like B? Like Kurt said, I can solve for B. So now I know B is 64 minus A. So wherever I see B, I can replace it with 64 minus A. You stop for a minute. Are you guys following along okay? So everybody had this problem, but nobody had this problem. So then what do I get? Why is this a better equation now? 64A minus A squared plus 7A. Why didn't I just add those? I don't know. We can do it right now. There you go, Jeff. Where will the maximum be? Why will this have a maximum? Why would this function have a maximum? Why would that have a maximum? What would it look like if I graphed it? And I'm not saying to graph it. I don't want you to graph it. But what would it look like if you did?
Parabola.
Who? Oh, parabola? What kind of parabola? Be more specific. Parabola opening
Down.
down. I like it. So of course it's going to have a maximum, right? How do I locate that maximum? What's another name for the maximum of a parabola or down parabola? What's another name for this point? Starts with a V.
Vertex.
Vertex. Do you guys remember how to find the vertex of a parabola? What the shortcut is for that? No, we don't. Okay, so if I want to know the vertex of a parabola, the x piece is negative b over 2a. Why does that get all freaky down there? I don't know. Can you guys see that all right? Negative b over 2a. Does anyone remember that? Very quickly. Isn't this, oh shit and a half, I got to be careful up here. Isn't this, oh crappity doodot, does this look, I'm too close to the top. Damn it. I'm too close to the sun. All right, hold on. Hopefully you guys know what I'm about to write up here. Isn't this quadratic formula? It gives you, and isn't this negative b over 2a, give or take, shit, right? I don't know if you guys remember this, but what's right in the middle of the intercepts? Isn't the vertex right in the middle of the intercepts? So that's why this shortcut makes sense. Does that sound at all familiar to anybody? That is the quick way to find the vertex. I'm a little tired of some of you guys using freaking calculus on this shit. Even if you know calculus, I don't care. This is not calculus class. This is pre-calculus. Don't be showing me any freaking calculus in this class. Be careful. And I'm not just talking to one person, by the way. There's several people that are doing this. Don't worry. So what is A and what is B in here? And I know I used A and B. That was probably bad. It was too bad for everybody. So negative B over 2A. What's the value of B from the quadratic function I have here?
71.
71. I love it. AX squared plus BX plus C, right? So that's negative 71. And what's A?
1.
No,
Minus 1.
negative 1. All right, so I get 35 and a half, right? I think. And then if I plug, and it's not X, Jeff, it's A. That's the variable I'm working with, right? If I plug this in, that's just the number that makes the product the biggest. If I plug it in, I could then I could figure out what that product is. So if I plug in 35 and a half, I can figure out what that maximum product is. You know, whatever the hell that is, I don't care. Okay, maybe. No, yes, that's exactly how you do that problem, right? I mean, based on what they tell me, I set up what they tell me, what they ask me, and then together it creates a quadratic. They want me to maximize something. It's a down parabola. Find the vertex. That would be the maximum. That's the optimization problems. Okay. How's that for everybody? You guys okay? You guys hating life right now? You're all like, how the hell am I going to do this? Let's see. What did I miss in chat? Let me know if there's any questions about that before I keep going. Let me see. Where did I leave off? So that's number 3. Somebody asked me about the practice final 16 and 20. I'm going to erase all this. You ready? Let's go. All right. So 16. Oops. Practice final. Oh, let me do this. Where's it at? Here we go. Oh, these here? Oh, yeah. Oh, yeah. So this is that Gaussian elimination, and this is the partial fractions that we all love. So of course I didn't give enough room for either one of those here. Let's see. I'm gonna bring back my, all right, so this is the question, right? Wait, I'm sorry, 16 and 20, not 17, 16 and 20. Oh, 20 is an easy answer. Remember parametric curves, x of t and y of t? So when you have to graph them, you got to make a t, x, y table. Does that sound familiar? So we can do an example of that if you want to, sure.
I just wanted to do an example because then I can kind of compile them with my other notes.
Okay. All right. So let's do, all right. So it doesn't matter which one we do first. So 16, just to kind of get that started. I got to keep it on the time too, because I got to, believe it or not, I have a meeting after class. The life of a teacher is awesome. Okay. So can somebody help me write this as a matrix? How would I write that system as a matrix? There is no spoon. How would I write that system as a matrix?
1, -1, 2.
Yeah, just collect all the coefficients. It's sort of like synthetic division, right? Get the variables out of the way. What matters are the numbers. 1, -1, 2, 3. -2, 1, -3, -4. 4, -3, 1, -8. All right. I have no idea if you want to do this whole problem, but here we go. Let's see how much we can do all at once. Does somebody remember like a good first step I could do? What's my goal, by the way? What do I want to make this matrix become? What's my goal? Goal.
1, 0, 0, 0, 1, 0.
Number. Why does that make sense? Because this would say x equals number, y equals number, z equals number. So I would be done. If I can get it into that form, if I can get it into the form of an identity matrix, which is ones along the diagonal, that means that I have figured it out. I have figured out what each variable is. Making zeros is equivalent to killing letters. How did we do this before we did matrices? Didn't I pick a letter and kill it and pick a letter and kill it again? Isn't that the same thing as making 1, 0, 0? Do you guys understand what I'm saying? Picking a letter and killing it twice is the same thing as making 0 show up twice. Does anyone get that? Everyone should get that. No? Because of course, if there's a 0 somewhere, doesn't that mean there's 0 of that letter in that equation? So that's what that means. All right, so how can I use this 1 to make this happen, to make zeros here, to kill these two? How can I use it to kill this? What would I do with this row so I can kill -2 here? Why am I using, all right, hold on everybody. Oh my God, please tell me I wasn't doing this the whole time. I was, sorry, I'll have to write that all again. I will never, ever remember to frickin' use, this is good because I can write it a little bit smaller. Sorry guys, hold on. I will never remember to use the appropriate editing tool at the appropriate time. It's just not gonna happen for me. All right, there we go. Sorry, somebody had a suggestion and I lost it. Where to go? Multiply what by 2?
2 times row 1 added up to row 2 and then equal row 2.
I like it. Twice row 1 plus row 2, put the answer in row 2. So the 0 ends up right where we want it. I like it right there. We want to make that 0. So if I do, let's see if you guys can handle this. Let's see if I can handle this shit. All right, let me zoom in. Maybe that's going to help me out a little bit. Holy crap. Yeah, okay. So if I multiply row 1 by 2, won't I get 2, -2, 4, 6? Yes? Multiply row 1 by 2. Right?
Yes.
Okay. And now if I add that to row 2, I get 0. So let's see what we get. We get 0, -1, 1, all right, 4 minus 3 is 1. 6 minus 4 is 2. Holy shit, Jeff. Let's calm it down, buddy. Now, let's see if you guys can handle this. I didn't really leave much space for this, but let me change my color again. Let's go with blood red. These are done. I'm done with those. They did their job. They're gone. How can I kill this now? So I can get a 0 here. What would I multiply row 1 by to kill that?
-4 times
Yes.
row 1 added up to. So
Add up to row 3, answer in row 3. So I get the 0 in the right place. Are you guys okay out there? And again, if you're one of the special people that either didn't really do their own homework or didn't do the homework, this will not be in your brain as much as it should, right? So if you're sitting there going, I don't remember this at all. Did you do the homework? Okay. So let me see if I can sneak this in here. What I'll do is I'll erase this. Yes, get out of here. I'm done with you. I'm done with you. Get out of here. All right. What am I doing this? Yeah, sure. So I'm going to multiply this by -4. So that's -4. -1 times -4 is 4. 2 times -4 is -8. 3 times -4 is -12. And now I add that to that. And there I get a 0 here, just like I wanted. And then I get a 1 here. That's nice. 4 minus 3 is 1. -8 minus plus 1 is -7. -12 plus -8 is -20. And then the first row, I can leave alone. All right, let me stop for a minute. Does this feel familiar at all? You guys remember this? This thing that we did not too long ago? Okay, one person. Oh, there's some chats. Oh man, don't be more questions. I got a lot of questions to catch up on already. All right. We're obviously going to take some of those questions tomorrow and the next day. I don't think we're going to be able to get through everything. Now look at this. This is so beautiful here. Let this be beautiful. Why is this so beautiful? I mean, this is like way too easy of a problem. Okay, I like that. Yeah, you should always be able to kind of tell how it's sort of like the way we would have done this by hand. Okay, now, can I use this to kill these? Because don't I want zeros around it? Couldn't I just, what could I do with row 2 and row 3? What could I do with those?
add them.
Add them. Row 2 plus row 3. Let me put the answer in row 3 so the 0 shows up where it's supposed to. Is anyone concerned about? Okay, nobody's concerned yet. Good. So the 1, -1, 2, 3. And then if I add these two rows together, 0 plus 0 is 0. Oh, I'm sorry, 0. Here, I want to put it here. -1 plus 1 is 0. 1 minus 7 is -6. 2 minus 20 is -18. And then let me put this. Now, what I'm going to also do at the same time is I'm going to divide this by -1, okay? You guys might be able to see why I did that. 2 reasons. I want a 1 here, correct? I want a 1 here. And now what can I do between row 2 and row 1?
Again, add them.
Yes, I can add them, just directly add. And again, this is kind of an easy problem, but if this was a 3, wouldn't I just multiply this row by 3 and then add them the same way we did on the first column? Yes? Okay. Do you see how once you know what to do in one instance, just keep doing that over and over, keep doing that over and over. I mean, it's kind of crazy. That's why it doesn't matter if I make the matrix bigger and bigger and bigger. It's just going to take a little bit longer, not a crazy amount longer. I just got more shit to kind of make zeros into, right? So now if I add Why did I do it at the same time? I don't know. It doesn't. I'm writing the matrix more than I have to, but that's okay. So now if I do row 1 plus row 2 and put the answer in row 1, I will get 1, 0, 1, 1, 0, 1, -1, 0, 0, -6. Oh yeah, what can I do with the last row, which I should have done already? What can I do with this last row?
Divided by -6.
Divide by -6. Okay, I'm going to stop there because I think I do the whole thing. I can't remember on the solutions video, or at least I have the answer there.
You do not.
I didn't. Okay, good. So let's go forward a little bit. Can't I divide this row by -6? I think somebody just said that. So that'll be 0, 0, 1, 3. Is that cool? Now, can't I use what's the last thing I need to make happen? What's the only thing that's not correct yet? Does the first column look good? Check. Second column, check. Third column, oh shit. Anti-check.
So we're adding them again.
Yeah, dude. So if I take this and add it to this. Now watch real quick. Why would I not want to add row 2 to row 1? Wouldn't that make a 0 here? But I definitely do not want to add row 2 to row 1. Why?
Because we'll get 0. We need 1.
We'll lose the 0.
Yeah, the cross.
The most important thing is zeros. You never want to lose a 0. Okay, and I have no idea if anybody completely hates matrices or loves matrices, or you're on the spectrum in between. Once you're more comfortable with them, they make these things so quick. And it doesn't matter how big of a system I've got, it's the same kind of thing. It doesn't really increase the workload that much. All right, so let's see. If I want to finish this out real quick, I would do row, you can do it, Jeff, row 3 plus row 2 to row 2. So that would be 0, 1, 0, 1. And then I could do negative row 3 plus row 1. Is that cool? To kill that 1 there. Let's see if we can handle that. 1, 0, 0. So this would be -3 plus 1 is -2. So what's my answer now?
So
How do you know which one's X, Y, and Z?
We totally know. From the beginning, what was this column? Where did these coefficients come from?
X.
Oh, there's a typo in this damn thing.
Oh, I see that.
Damn it, Jeff. You flipping past Jeff. Hopefully you guys kind of inferred from the context here. That's a Z. I didn't mean for that to be a trick question, but yeah, you in order for this to work, these have got to be the X's, the Y's, the Z's. Sort of like synthetic division. Don't I have to put a 0 in if I'm missing something, and it's got to be in decreasing order, correct? And the minute I've got that like that, I can ignore the variables because now I know what each number represents. So I can just do the work without the letters. Yes, so now I got the answers coming in. So X is -2. Y is 1. Good. I keep wanting to say Z. For some reason, I'm channeling one of my old teachers. Z is 3. Z is not dead, baby. Z is 3. Okay. All right, so let's do this. Let me see. Is there a quick question somebody had? Or holy shit, I got to go back a ways. Oh yeah, so somebody wants to review converting equations. Yeah, that's a huge one. So why don't we do that topic either tomorrow or Thursday? Say again, sorry.
Were you gonna do an example of the number 20?
Yes. All right, so we could do this. Let me see. So parametric curves are these kind of guys. Remember this? Where I can say x of t is what, Jeff? T minus t squared, and I can say y of t is t plus 1 over t. Why not make it weird? And I would tell you that t, let's say t goes between, what do you got, Jeff? T goes between 0 and 2. Why not? That's gross. Oh, it's too bad. Too bad. Does this feel familiar, anybody? TXY, make your TXY table. So if t is 0, I get 0 and oh shit, that's not good. Let's make
Do
this.
we-
Sorry, it would make that undefined. So that's not a good thing. Let me make t go from 1. Let's make it go from 1 to 8, just to make this a little bit less crazy. Believe it or not. That's probably a bad idea. Does this feel familiar to anybody? So now, so I can't use t equals 0. I'm sorry, because the way I set it up, that would make y undefined. Are you guys with me? You could actually do it. You could actually have a asymptote on this, but it's already hard enough on its own. So 1 minus 1 is 0. Is that cool? So I just plug in the value of 1 in, and I get 1 plus 1 divided by 1 is 2. So then if I use 2, now if I need to, I can increase my resolution by putting in like t equals 1/2. Do you guys remember this? If I need to, I can do a little bit better
Do
resolution.
we not use angles?
Sorry?
We don't use angles for this?
Not necessarily. Was there any trig functions here?
No.
So remember, I could have a parametric equation defined in terms of trig functions, in which case I'm looking at my inputs as angles. Yes. That's not how this is defined, right?
Okay.
Okay. So then 2 minus 4 is -2, and 2 plus 1 divided by 2 is 1.5. Are you guys? And then when you go to plot this, you plot these points. This is in the background. This doesn't show up. Remember that? T is like the background. T is like the person turning the dials on the Etch-a-Sketch. They don't show up on the Etch-a-Sketch, but how quickly I turn the dials changes what the XY points are, but it doesn't show up. Does that make sense? There is no. Go ahead.
Sorry, I was mixing it up with the circle graphs.
The polar curves. Yeah. So I'm doing parametric. So this is a parametric. Parametric are points defined by a third background parameter. So that's parametric equations. So this would be 0, 2, -2, 1.5. And then I would keep going. And then these would connect with an arrow, bam, bam. Remember that? You can show the direction of motion. Maybe. And then, I mean, I could keep going. Well, let's do this. I don't want to shove this in at the end of class here. And I also need a few minutes to get ready for my meeting. We'll do this first thing tomorrow. We'll start with parametric and polar stuff. We'll do a polar curve. What you're thinking about is something like r equals 2 cosine of 4 theta, right? That's,
Yeah.
yeah, good. Okay, no worries, Paul. So we'll do examples like number 20, and then I'll have to, whoever put a chat question in, you're gonna have to bring those back tomorrow, okay? So tomorrow and Thursday, we're devoted to review. So just come ready with any and all questions tomorrow and devoting all those days to review. And I'm trying to make sure somebody keep me on track. I'll definitely do all the problems on the practice final that I did not do in the solutions. I think there were some that I did in class last semester, so I'll have to do those in class for you guys too. So they're not worked out on the solutions video. Let me see, there's another chat coming at me. Oh, you're welcome. All right, guys. So let me know if you need to hang after, but otherwise class is over and I'll see you tomorrow.
Thank you.
Sure.
Wait, Professor, I want to talk with you.
Yeah. Oh, why do I have this open? Oh, yeah, that's right. Thank you.